Okay, let's wrap that up. So we 3 minutes late. Sorry for that. Not good with timing, but I'm very good talking with students. That's done not really helpful. So, bet on me. Two things before I get there. So I want to talk about REST, but also there was a few people asked already about cheat sheets for Vim. You guys talked about Vim a bit, right? Did you? Yeah. Please? Good, thank you. Because I don't want to talk about Vim. So you find a cheat sheet in the teaching wiki at the bottom there. So that's something we continuously made up over time, and it basically has the base functionality there. So that's like the cheat sheet for the beginner kind of thing, right? So it doesn't have any Go specific aspects in there, no extended macros or whatever. You just use the base commands, so just be comfortable and being able to switch between different modes. You talked about modes, I assume. Normal, visual, replace mode, and so on. Insert mode mostly. And then closing files and moving simple substitutions, jumping around in files, moving to the end of a line, jumping between words. For example, W allows you to jump it from word to word. If you use the capital, but it usually stops at punctuation. No, it does stop at punctuation. Not usually. It always stops at punctuation. And then capital W ignores that. You can jump to specific lines if you like, or activate line number settings. So those simple ones we have added as well. Copy and paste stuff. So deleting lines and copying lines for yanking, for example, and pasting them elsewhere. Searching, simple substitution, and selecting blocks. So that's the kind of scope that we start off with here. So you have a simple overview. If you find, and that's the point, it's hosted in a repository, if you find some other extensions or commands that should be in there because you deem them necessary even as a basic user without any custom extensions and so on, just make a pull request and change the documents, submit a change. So that's a good idea for actually getting used to dealing with pull requests anyway if you're contributing to a public system. Did you guys learn about LaTeX anywhere, anyhow? Mets? Cool, really? For Mets, for the Mets package to write mathematical expressions? Did anyone else learn it? But you're a bit ahead of the game, right? Isn't it? Somewhere, cool. So this is if you're keen, the whole sheet is provided in so-called in LaTeX, which is basically a macro language that allows you to write beautifully laid out documents without caring about the layout, because that's what you get. But you can directly edit them. They're text-based, therefore perfect for versioning. Note, you'll need to use that in your bachelor project anyway, so it's worthwhile getting your head around it eventually. There will be some intros, I believe, traditionally run by Simon, I believe, or the library?
Yeah, Simon had one last year.
So we need to do it again eventually, but so meaning you can directly manipulate and play around with this and then compile it. But I'm not going to LaTeX right now, of course, but here just the pointer, there's a Vim cheat sheet. If you want to change it, go for it. If you don't know how to modify the LaTeX thing, just send an email and say, hey, there should be something in there. Or raise an issue, even better. So people can vote on it and think about it and stuff. Cool. All right. Without even more further ado, REST. So that's some of the things that we need to talk about as well. Mariusz next week will talk about the net HTTP library in Go, which is like the standard way of dealing with network access in particular and web service modeling specifically. And we just want to give you more like a theoretical insight on what REST actually is and what it means and what the intuitions are behind it before he actually applies it. Also, that's necessary to understand the assignment. You may have noticed or may not have noticed that I brushed over the assignment a bit last week. So I said, hey, have a look at it and good luck. And the reason is that we didn't talk about all the fundamentals yet that you need to know to understand what the specification wants you to do. But I hope after this session, it would be worthwhile for you to go back to the assignment, have a look again, and probably comes together more sensibly, and you may be able to assess it as well, whether there are gaps in the specification, which may be the case. We forget stuff as well. So, Okay, so today I briefly want to talk about REST and the idea of RFCs. We get to that in a second. Who's that? Classical picture. Yeah, cool. Well done, cool. Anyone else got the same intuition and didn't dare to mention it? Who did it? What did the guy do anyway?
He invented
He invented the World Wide Web, right? So not the internet, but the World Wide Web. So what was the World Wide Web? Well, what principle did he basically invent?
Not sure.
Okay, so basically quite straightforward. Everything you learn in a 101 web class. That's what kind of stuff he invented, which includes, you know, having some sort of HTML layout of the web page, but most importantly, the concept of the hyperlink there. At least the use of the hyperlink. Not sure if he invented the hyperlink idea per se, but using it actively. So he built the first framework that allowed you to basically have links on pages that link to others, you know, other websites and basically show their web pages. His problem was he was working at CERN in 1991, or in the end 80s rather, was realizing that it was really hard to find information about each other, right? People don't really talk, you know, you have a large research institute and it's pretty hard to talk to each other, know about everyone else. If you guys want to figure out who's teaching cloud computing or mobile computing, you type, you know, NTNU cloud computing, and you most likely end up on some web page that gives you some meaningful information. You point to the, you know, course coordinator and voila, you know what that person does. So it was very hard at that time, unthinkable nowadays. So he came up with the first solution to that problem, providing the basic protocols that accommodated this, like the HTTP protocol, HTML for layout, no CSS at that time, and of course, again, the link idea. So, and he wrote the first browser. What was the name of the first browser? Anyone knows? It's just a historical artifact, not critical. No, not quite. The name was Mosaic. Okay, Mosaic browser. Yeah, anyway, so cool. So that was the web in very short version. You get some intuition of what was happening. So he was coming up with the first protocol, of course, not the current one anymore. All right, so, but we're not stopping there. Why do I bring this up? Well, the original web protocol was actually quite powerful. It allowed you to view web pages, and most commonly and most often not really understood, also the fact that you could use the web protocol or HTTP protocol to change web pages. The original idea was also not only to read content, but also to write content. So if we're talking about the Web 2.0, which was around 2010, which was kind of super hot there, or, you know, in the 2000s, super hot, that was basically already available technologically, but it was just not used. So it's one of those examples where technology is oftentimes ahead, but it actually has never caught the mainstream, and you need something like Facebook to actually make people clear, you can write something as well to the web. So, okay, so so it was all there, but it was not really used, and there was no really a clear strategy of how to systematically change and manage resources on the web itself, other than viewing pages and, you know, following the links and, you know, looking at content. So, and that only happened in roughly 2000s when Roy Fielding, in his PhD thesis, talked about the concept of representational state transfer. And what is that? Well, you know, there's of course some fancy lingo associated with this, but the idea is, at least that's my interpretation of it, it's how to properly use the web standards to just handle resources or state on web servers. Yeah? And the idea with state is there that we can change resources on the web, right? On web servers, for example. Not only access them, but use them as well. So REST, or representational state transfer. So if you hear that, you know what it kind of refers to. It's basically a specification of how to use the web protocols properly, in a way. Because most of them were actually available. He is, of course, involved in many of the standardization groups, working groups that have to refine the web protocol and so on to accommodate this aspect. A central protocol is the hypertext transfer protocol, HTTP, as you know, which basically allows you to send commands and send methods and content to web server. We get to that in a second. But what is the fundamental idea of the REST system? So the REST system was basically a bit more of moving back and thinking, okay, how do we actually build a proper system? And one of them was actually the idea, or not the idea, but the understanding that we need to clearly separate client and server. So server is responsible for managing resources, client is responsible for displaying stuff and interacting with the user mostly. So the idea is increasing the portability there. So it also, in principle, implied that we should not be tied to particular browsers. I don't know. Perhaps you recall there were browser wars, Netscape against Microsoft, that kind of stuff. And that was a time where many of the web standards that were popular were kind of often specific to those browsers. So you kind of needed to use Internet Explorer to use a web page properly, that kind of stuff. And this should be totally thrown out of the window. So it's really about any client you can write. And in fact, you write a client in Go, so not a browser, that can afford the same functionality. So state should not be held on the server. So if you're interacting with the server doesn't need to bother doesn't need to bother keeping track about the state that the client holds. Meaning, if you're loading a resource, want to change it on the client side and post it to the server, those should be independent transactions. So they should not be linked. The server doesn't need to retain this state at all times. It just needs to know, okay, this resource should have changed, and you just reflect that change atomically, but you don't really keep the session alive in a way between those different interactions. Of course, cacheability. So for performance reason, if you deal with state and you have a client side that accesses it, sometimes you need to be able to cache information, right? So you know that from browser cache, if you're just accessing a static web page repeatedly, you want to have, want to load it quickly and not transfer the entire page if it didn't change anyway, right? So there needs to be some way of dealing with this, signaling, okay, this resource has changed or not changed, therefore don't bother downloading it again. Does that make sense? Ish? Easy, right? So, and the layered system, that is the idea that there should be proxies in between, or load balancing should not be a problem. And most important, that's an interesting one. I'm not sure if it's actually used, code on demand. The original REST specification also suggests that you should be able to send code via the HTTP protocol, meaning you're sending some JavaScript code that's supposed to be executed on the client side. Sounds shit dangerous to me, but yeah, I don't know. So they probably didn't really think about this one, but it's in principle an underlying idea. But most importantly, it's the uniform interface. And yeah, so how does it work? Fundamentally, it boils down to having some sort of resource representations that you can download, manipulate on the client side, and then upload on the server again. And everything needs to kind of be self-descriptive. So the idea is that the AP is nearly self-descriptive. And again, it's just an idea. It not necessarily means that it actually is the case for many REST APIs. Good REST APIs do that, but many ones actually don't do it. And there's another one. I just put it out here, not something to learn by heart, but if you come across this, hate OAS. I don't like this acronym at all. But so hypermedia is the engine of application state. What it says is basically, when you, I'll probably show you in a second. No, I'll show you an example of what a REST request looks like. That's probably something I should have done a bit earlier, but we'll get there. And even the wiki page has a good example, I think, already. So here that would be a classical kind of information you would get. There's a request to a bank to download something, and you get this in return. And here it says, well, you have an account. That's XML, basically. You have an opening tag and a closing tag, and you have an account number. That's the account number. That's the balance they have in your account. It's like the most simple way of kind of playing with XML. And the idea here is then the actions that are associated with this, for example, depositing, withdrawing, transferring, or closing an account, should be described in links themselves. So if you think about databases, that would correspond to the idea of normalizing a database, right? That you only define everything once, and in all other cases you have pointers or references, foreign keys or whatever else, in the equivalence of relational database management systems to actually point to its definition. So if it changes, it only changes in one location, and all references will be consistently reflected that. That is the idea there. So you don't really replicate and copy content across different services and so on. Okay, right. But since I mentioned there's a bit of conceptual background as well, where's REST actually specified? And it happens to be specified in an RFC. So a bit of an excursus. What's an RFC? Cool. What is it about?
I guess it's when people want to some sort of create a new protocol or some sort of route, they come up with some sort of request for that, so that the others can actually look into it and actually develop a new protocol. In that case, I guess.
Yeah, perfect. So that's a very good summary. So yes, as part of the advent of the internet, or ARPANET at that time, 69 around that time, there was a lot of need for protocols, of course, for everything, right? Connectivity, name exchange, email, DNS, you know, all that kind of stuff, right? And that was basically just a chunk of paper that was lying around somewhere because people had ideas and thought, let's do it, try it out, it worked, cool. But how do you document it, right? So, and there was, 2 years after that, there was then the motivation to say, okay, we need to structure that process, right? We need to kind of know what the standards are we actually use it, right? And they came up with the idea of a request for comments. And originally, precisely for the purpose you highlighted there, it was not so much, here's your standard, good luck, here's an idea, please give me some feedback, and then we make something out of it. It has gradually moved into becoming a de facto collection of, you know, proposed standards, if you like, oftentimes rejected or deprecated, but in principle generally accepted. And there are various fora, or plural from forums, I don't know what it is in English, that publish so-called requests for comments. And they're basically kind of often generally published in plain text, have a status associated with this, and publishers are the Internet Architecture Board, which kind of oversees the so-called IETF, Internet Engineering Task Force, the Internet Research Task Force, which is a bit more of exploring research directions. Those are more like standardizing actual use, best practice and so on. And they all publish requests for comments. Yes, so there are a few other ones, of course, that you guys have heard of, right? So that's the IETF, that's the most common one we'll be reading about. W3C, you guys know that as well, right? So it's the World Wide Web Consortium. They're also more involved, but more on the application level, web protocol level. That's where they generally have their working groups, for example, semantic web, things like that. XML specification is under them, for example. Whereas IETF sits one level lower slightly, so a bit more on the transport level, so transmission of data. ITU, who the heck is that? It's good to know, but yeah? No? Do you have an idea? No? Cool. Okay, then we ignore that. No, it's the International Telecommunications Union. So they are actually responsible for specifying telephone numbers. So they were responsible for the baseline addressing of the internet and the protocols for interacting. For example, they are related to the specification of, for example, wireless LAN, things like that, for the access layer, basically. And ICANN, which is responsible for what? Guys, come on. Really? Is it too easy or too hard? ICANN, anyone? Please. If it's too easy, throw a rock. If it's too hard, just give it a go.
It's the National Corporation for Assigned Names and Numbers.
Brilliant. What do they do?
It assigns like DNS
Yep.
names.
Domain names, right? So it manages the top-level domain names like country level and so on, and delegates to other local institutions. For example, .no is kind of managed by them, but actually everything below that is managed by a Norwegian registrar, right? Most likely. I don't know the precise system, but generally it's a delegation-based system. They sit at the very top. That's right. And the other thing they also manage is port numbers. For example, the fact that port number 80 is for web services, unencrypted web services, or 443 for encrypted ones, managed by those guys. Cool. All right, enough boredom. Well, you're not get away from this. But it's important for you to know where do I look up if I have a question about a standard. That's why I'm doing this exercise here. So requests for comments, they are quite relevant. And they have different statuses. I just bring up one just to see, so you can see how those documents actually look like. And this is the first standard as part of the REST specification. Yeah, good, lucky me. So that's how they roughly look like. So you have some sort of proposed standard information. Here's the information that there's actually refinements of that standard already. Here's the authors. You know, Roy Fielding, the guy who came up with the REST, is still very involved in this. This is from 2014, so actually not too far off, only 4 years old. And on the left side, you see the body that specified it, the ID of that request for comments, so you have a reference to it, and the relationship to other RFCs, so which ones are obsoleted as a response, so earlier specifications of the hypertext text transfer protocol, for example, and which ones have actually, where are some additions and additional updates specified. So it closes the link between all those different RFCs, so it's quite important to be aware of. because otherwise it's pretty easy for looking at an obsolete RFC and thinking that's the latest standard, right? And you notice the category there as well, it says standards track as well. That's the other aspect. So RFCs can be kind of informational, standards, experimental, or best current practice. So those are a few of the different statuses, so you need to be watching out carefully of what you're looking at. Usually standards track is the one that is mostly relevant. If you want to get an overview of all the relevant standards, just bring that up briefly, hang on. For us in particular, since we're not so much specifying standards but rather using them, you want to be sure using the latest thing. rfceditor.org/standards lists current standards and associated the links to errata or updates and so on. So it's a wide range of stuff you find here in the specification. The SMTP, which is mail transfer protocol, file transfer protocol, and so on. So if you browse through here, you'll find all the standards that we commonly use, and if you feel like you want to use any of those standards, you can, because they're all still current. Okay, but the structure is roughly like that. But coming back to the idea, coming back to REST. So we had this earlier standard here, and it's quite explicit about the fact that, so that's like the overview of everything that's contained here. But part of this here is an introduction. This is the first RFC that actually starts specifying REST, but it has a set of other RFCs relate to it, to specific aspects: semantics, contents, conditional requests, caching, authentication. And we, for our purpose, are mostly interested in this one. And that's something I would actually recommend you to actually have a look at, not comprehensively read it, but to actually look at use the overview, the table of contents to guide you, because most of the answers you may have, you will find here. So what is REST about? The idea with REST is that you have a uniquely identifiable resource, and uniquely identifiable therefore means URL, right? So you have some URL that points to some resource on the web. Let me just come up with something, hang on, because I have here one, so let's see. So we have something to demo. Good. So it's a demo one restcountries.eu. And what does that do? It basically lists resources. In this case, there's a lot of resources, so let's make it a bit more concise. It lists all countries basically, and a lot of meta information about different countries. And in this case, I narrowed it down to Norway. If you had seen before what I did there, the API basically started off with restcountries.eu/rest, just to indicate, okay, everything from here on is a REST API. It follows the REST principles. Then the version 2 apparently, and all means all the content that you have, all the resources that you manage. And in addition to that one, so that was all the countries. Oh God, shouldn't have done that. Should be a cacheable request though. So lists all different countries, starting with Afghanistan, Albania, and so on. So it's quite a list. But you can narrow it down by also not only accessing the collection of all the resources, but individual resources, such as in this case done Norway, right? All the information about Norway, its name, top-level domain, what is else in there, calling codes, the 47, for example, latitude, longitude, population. So the idea is just a project that collects like meta information about all countries. But this is kind of a practical example for resource. And if you look at the RFCs, it comprehensively specifies how you can actually modify resources. That's the key idea there, if they are there. Of course, not all web servers need to provide this functionality, but it's an extension to HTTP saying every web service that conforms to REST needs to provide the get and the head method. So we have the idea that we have different methods that allow us to modify state. So what I did just now when calling this web page, I did a so-called get request, right? So in HTTP specified the method get. Then if you have the head request, it just gets the status line that you see on top of your browser and the header section, so meta information, but not the content. So if you have constrained internet access, the idea is there that you get a gist of what's happening there without getting the actual content. And there's other functionalities such as posting, put, delete, connecting options, and trace. And it boils down to the representation of the, again, last week I talked about CRUD again. I usually like that example, create, read, update, delete, right? And this is precisely what you can do with the REST protocol here. So you can create resources using the post method. You can read resources using get method. You can update resources using the put and the patch method. We get to that. And of course, removing by deleting. The rest is meta-informational stuff. So that's the kind of methods that are specified by the RFCs. And there's one tool called Postman that I bring up right now to give you a better picture of what's actually happening. So see if I still have that. No, yeah, cool. I still have that URL there. I will do name Norway and do a GET request. So it's get. Here's a bit more readable to some extent. So it's the structured approach. This JSON output. We didn't talk about JSON yet, but point is it's a description format, interchange format that is, structures the content so you can read it across different operating systems and languages because it's a very explicitly specified structure. But that's not the point I want to get at. So if you have a resource, the resource identified by URL, you have a method attached to it that you want to use to interact with the resource. In this case, getting, read the resource, but it could also say post to the resource. But that would require this resource, of course, to be writable, which may not always be the case. Yeah. Similarly, able to delete it and so on. So it's a lot of methods that you apply. In addition to that one, you generally have some sort of header information. And that's, in practical terms, it describes the structure of the content that you're submitting or receiving. Right? So if you're getting, for example, content from a web page, and you want to know what the structure is, it needs to describe, that is actually, for example, text, or in this case, it's an application-specific format called JSON. Right. Bear in mind, the idea of content types was defined before many of the content types actually have been defined. So that's just an open-ended concept. If you define a new data structure format, you can call it application/my format. Right? So it just assumes that both parties need to understand what it means, but it doesn't have any specifics attached to it, right? So if it's just a format that they understand, then the protocol can be indifferent about what the actual content is. So the header information, and the last thing that you, of course, get as a response from a request is a status code. And you guys are, I think, reasonably acquainted with status codes of HTTP. Yeah. Yes, cool. 404, yeah. Other ones?
200.
What does 200 do?
200 is okay.
Cool, you cheated, okay. So, what other ones? Any more?
500.
Okay, let's structure that a bit and be a bit more systematic. So,
you have the 300 series.
Okay, what did I do?
Mostly redirects. 301 and 302.
Very good.
Are,
what is a redirect?
If you have a server that redirects me to another server.
Yeah.
If you move a server to another domain, for instance, you can do a permanent redirect, which, if I remember correctly, is a 302.
Yep. Cool. That's right. So, so all those different status codes have a particular purpose. So it's not only that you need to know the specifics, but if you know they're in the 100, 200, 300, 400, or 500 category, they give you different kind of information, right? So, for example, 100 are generally only informational. It doesn't matter. So practically you don't see them anyway, because they will be usually consumed by your browser internally and does something on it. Similar to the 300 ones, many of them. If it's a redirection, your browser gets the 302, for example, and redirects to the URL that's specified in the body of the response. So also something you don't interact with.
One good example is actually when setting up HTTPS, you do a permanent redirect from HTTP to the HTTPS.
Exactly. Right. So you have HTTP on port 18, you redirect to port 443, right? Yeah. So that's right. So that's a classic one. But usually not something you see. But for us, more relevant are the 200 ones that indicate generally success, so that something worked out with some additional context information. So, so typically it's 200, everything is okay, cool, well done, okay. But usually empty body. It doesn't need to be empty body, can be. That 201 is a good one as well. If you say, for example, you have a post request and you want to confirm, give the user information, okay, yes, it worked out, and actually something was created as a response to that one. That is
results.
Exactly.
Everything up to 204 should have content to it. If I read the
which one? 3?
Up till 204.
Yeah.
should have content,
Yeah.
if I remember correctly.
Yeah, I suggest that, right? In the post request will contain an entity describing and saying, yep, cool, that sounds good. Yeah, so you need to specify content. And 204 is the classic one where you don't get content. So something happens successfully, but you don't get anything back. It's basically just the meta information telling your consuming device, don't expect anything in the body, but things worked out, so what? Right? So that's kind of the thing. So there's a lot of more refined statuses, but in many cases, people just resort to using the first one, 204. You find it sometimes here and there. The 300 series is redirects, as we find here, so quite, yeah, not in practice too relevant. Yeah, so the reason why I'm coming up with this one is that when you write a REST service, or when we talked about writing a REST service next week, you need to specify the resource, including the root URL, the methods that you use to post information, for example, the structure of the body that it's supposed to be posted in, and also give a return code if something happened, right? You're writing a server, someone sends a request, and you need to give an appropriate response. That's why we're going through this exercise here a bit. 400 is client-side errors. It says, well, you know, the server tells the client, you did something wrong. Your format is wrong, or you're not allowed to do something. But the classic one is probably 403 for forbidden. Yeah, 404 for not found. Does anyone know a rather unorthodox one? Timeouts. So those are classic ones you find. Payment required is a weird one. So if you should actually browse through and have a look. They're quite funny. But before I let you go,
413 or something like that,
nah.
Where there are actually multiple definitions. I don't remember the number.
I didn't mean something serious. I meant something useless. 418. I'm a teapot. So that's like the idea is that.
I protect coffee protocol or something.
So this one has been removed from the official. From the official standards, of course, but it's still operated by many of the provided by web servers and so on. So it's just a April Fool joke, basically, that it's returns some sort of representation of a teapot. Anyway, so but there's a lot more of them. You find that many of them are actually not used. WebDAV, for example, was what I mentioned before. The protocol that allows you to write to the web, the authoring protocol and versioning protocol, hardly ever used.
So is it just an integer to the client, or how does it?
Yeah, that's right. It's represented here, the response. Yes, that's a very good one. So it sends the status as part of its information, and a content type attached to it, so what's the structure of the content is, and some body of whatever nature, right? And the headers can be richer than that, and of course hold more key value pairs, but the status is just any request sends some status back. It just tells the browser, okay, that's what happens. For details, look into the body, right? So, but in many cases they are self-explanatory, especially in successful cases, like the 200, 404. But 404 browser will just say, well, resource not available, and you guys all had this kind of issue. So it's part of that standard there. And if we go back to the RFC for a second, you'll find that all of those are actually specified here. And if you want to know the precise semantics, this is the location to look at. Yeah? So the RFC 7231 is the one that is relevant for all REST-related things. So if we, for example, tell you, please write a REST service that does the following, and we forget something to specify something, which may or may not be intentional, it's your duty in a way to figure out which return code or status code, for example, is appropriate for a response. We sometimes don't give you information, sometimes don't, because we assume it. But it's your task to think about this to some extent. And it's fairly feasible. Cool. So the 400s are client-side errors. Last but not least, someone mentioned the 500 ones, right? So that usually means something went wrong on the server side. So if you get processing problems, your parser blows up, or something throws an exception, you get an error in your Go code, you throw a 500 status code. You tell the client, you need to give feedback. You tell the client, okay, something went wrong. On my side, I don't know what it is. I let the administrator deal with this, but you know you didn't fuck up, it was me, right? So that's the kind of status code you deal with this one. So usually 500 is a very classic, which you probably want to implement somewhere.
So a lot of languages actually do implement subsets of 500. So developers might actually get to know 500's point something.
Right. Okay.
in the error page to know developers,
Right.
to let the developers know what actually happened.
Right. Okay. Yeah. Yeah, but it's more. Yes. Okay, but that's more like for the informational side for the logs,
Yeah.
right? So, but from a client side, you want to be as. You don't need to be too explicit because it's also a vulnerability, potential attack vector, right? If you give details of what went wrong, yeah. Sorry, your
Yeah.
database credentials A, B didn't work, is not necessarily good feedback to the client.
And that should be a 401.
That would be a 401, exactly, and then you ignore that the rest entirely, right? So things like this. Note, please, that the error codes are actually built into the net HTTP, Marsh will talk about it, into the API itself. So you don't send back a 500, you send back the constant that is registered in the API. So the point is, the idea underlying is that if it changes, then it's immediately reflected correctly as opposed to being a hard-coded, magic number. But that's another thing. So there was a question about meta information headers. There's, of course, a lot of them. I'm not going into many of them, but the one that's relevant for you is, as we just saw in the example, is content type. So this is the header information contextually that can be provided. It talks about encoding the character set that's accepted, languages. Yeah, but realistically, well, something that's oftentimes found is referrer. That's the where you're coming from. The user agent is the browser that requests something. But realistically, the thing that you need for parsing is the content type. And please note that content type is always spelled with a dash in between as a header. I noticed that people will omit that, and I promise you, some of you will omit that in your coding as a header types, because you need to tell the other party what structure your code, your content is actually in, right? JSON and so on. That's the key idea. Cool. Content types are specified in this context. Please note that this specification was actually done in the context of email attachments. So you see how the standards are all over the place. When they had the problem that they need to send emails with media files, for example, as attachments, they need to figure out, okay, what do we do with the old-fashioned email format, which only considers text? So they came up with the multimedia extensions, and that's where they started using content types. And those, again, have been borrowed for the REST services as well. So you see how all this tangles up across different standards. Yeah. And what you find, specifications for content types is always something like this, that you have a top-level media type and a sub-level media type. So that's the text, image, audio, video, application are the standard ones. And then you have something specifically like text plain, yeah, or image JPEG, or image PNG, right? So it says one thing, it's an image, and that's the format. And similar for everything else, in my view, it's always application / whatever else. Because JSON came later, it was then application / JSON for if you have a JSON encoded content. I think it's, what is it for XML? I think it's also application XML, text XML. One of those, I forgot. Anywho. So this is basically the specification of content types. Cool. So a good REST client for playing around, also to test your own REST web service, I recommend you to try Postman. But there are other ones, of course. But this thing works quite well. I've tried it for a while. And it allows you actually to play around, inspect a lot of things. You can try your different methods, of course. You can inspect the headers. You can provide a body. For example, if you switch to post, you can now specify a body if you want here. This is invalid. JSON, we'll not manage to talk about JSON for now, but probably need to brute force that into the next session. So that would do. And so here's, for example, one body that you want to send using a post request, and the header that specifies, well, the content that I'm going to send will be, so the body content, will be in application JSON, so meaning in JSON format. And then, of course, you need to send it to the right URL. I think I have a dummy service here. So then you can just post that, and hopefully it kind of works out. So and it gives you return type 201 created, right? And this is also a response body that you receive here. You see it's a JSON extended here with an ID that tells you something about the resource. So if you notice the one before, it was just title body user ID. Here's title body user ID and an additional ID. What does this ID tell you?
The ID?
Yeah. Well, it's an ID, right? So it's usually an indicator, okay, this may be a navigational aspect in the sense that you can now access this post. Note that the API is dummy one, so it will probably not work, by actually changing resource, the URL. So we created a new resource created with response, and you can just expand the URL, so the unique resource identifier, with 101 and hopefully get feedback. And in this case, it's an empty field because, again, I mentioned this service doesn't actually work properly. It just accepts dummy requests for tying out. But you get here 404 not found, so it's an empty JSON request in this example. But if you, for example, access post 1, which is also, I do a post. I need to do a get, sorry. Thank you. I heard someone mention that it was good, but still not found. So you need to get the right method. So I posted something, and afterwards I want to get it with the unique identifier. So there's a difference in those URLs. If you have the root of a particular service, it generally often prints all the resources managed. But if you want to have one specific one, you need to identify it somehow. And what you just saw before, there was an example of being self-descriptive. By adding a new attribute, you know, okay, that's the new identifier I can use and navigate. Yeah, so you'll play around with this more on Monday and hopefully more applied with NetHTTP when we do it in context of Go. Until then, just what I want you to do is to be aware about what actually a request needs to contain. So we have URL, content type, a body, and status codes. Those are key elements. Have a look at the RFC, and foremostly important, because it's 10.01 right now, have a look at the assignment and see if it all makes sense. Did we specify a post body correctly? Did we specify the status code you need to return? Does the get work? So does it all make sense? Can you manage a resource with the commands that we specified as part of the assignment layout? Yeah, using the knowledge you just obtained. Of course, I was really rushing over it, so you may need to look into the specification, which you now know is found here, right? This one is the one for us. RFC 7231 is the one that specifies content and semantics, including status codes and the methods. So please read through the methods definitions so you get a lot of more understanding. Questions for the ones that still can? I was rushing, I know. Please?
Just you said tea on Monday, isn't it?
Tuesday, sorry. Yes, you're right. Tiersdag. My Friday brain. Thank you very much. Good. Tiersdag, of course, right? Tuesday, not Monday. Any other question? I put the stream online. I noticed I kind of streamed it wrongly last time. I need to move that recording a bit. But so you can play it at 0.5 speed, so you actually can follow what's happening there. Because I was talking a bit fast, I admit. So I want to get some stuff done. You know? Did anyone get anything out of this? Okay, survived? Okay. Have a good weekend.